Find the equation of the sphere if one of its diameters has endpoints something and something. So now we know two endpoints of one of the diameters of a sphere. So I draw the sphere here and then say we know this diameter. Okay, two endpoints. One endpoint is of the coordinate -3 to 7. The other one is this one. So to find the equation of the sphere, we will find the center and the radius, right? So we find the center of the sphere and find the radius of the sphere. So the center of the sphere is the midpoint of this diameter, right? So the point, say this one. So we know this part equal to this one. The length of the two segments are the same. Okay. So the center of the sphere is the midpoint of the diameter. The diameter. So the diameter we are talking about here, or I say a diameter, and we pick this one. So in our case, we have the center is of the coordinate. Say for example, if you have x1, x2, x3, x1, y1, z1, and x2, y2, z2, then the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So this is, by 2. This is the coordinate of the center. So in our case, we have -3, -1. In our case, so we have the centers -3 plus -1 divided by 2, 2 plus 6 divided by 2, 7 plus 13 divided by 2, which is -4 divided by 2, so -2, 8, so it's 4, 20, so it's 10. Okay, so this is the center of the sphere. So we computed the center. Now the radius. The radius is half of the length of this diameter, right? So now we compute the length of the diameter and then we divide it by 2. The radius of the sphere is half the diameter. So we have radius, say r, equal to 1/2 the length of the diameter, and we know that the length, or maybe I just write the diameter, and the length of the diameter is the length of this vector, or should I call it AB? Okay, A and B, right? So this is, the radius is 1/2 times the magnitude of vector AB. So 1/2, remember we have the formula, right? the formula of the magnitudes of a vectors. So let me recall it, because A is a coordinates x1, y1, z1, B is x2, y2, z2. So that is x2 minus x1 square, y2 minus y1 square, z2 minus z1 square. So this is the general formula. In our case, this is 1/2 square root of this is our data. Square root of -1 minus 3, right? So +3 square 6 minus 4, 6 minus 2 square 13 minus 7 square 1/2 square root of 2 square 4 square and 6 square. So in our case, what do we have? 1/2 4 16 36. So this is 20 36, so 56. So 1/2 square root of 56 Okay, we have the center of the sphere, which is this one. We have the radius of the sphere, which is this one. Therefore, or say an equation of the sphere is, let me get the center. An equation of the sphere is x minus -2, right? Square. So maybe I should recall that from you. So the general formula would be x minus x. So if I have x0, y0, z0, and r, we have the x0 square, y minus y0 square, z minus z0 square equal to r square. So this is a general formula. In our case, we have y minus y0, which is 4 square, z minus 10 square equal to r square, equal to 1/2 square root of 56 square, right? So I can write as x plus 2 square, y minus 4 square, z minus 10 square, 56 divided by 4. Right, okay. So this is our equation for the sphere.